engine swaps, EFI conversions, and modernized classics.
Good afternoon, everyone. So here is our 190 project, the one we talked about a bit in one of our videos. So it's about to undergo the major surgery we talked about before, meaning we are going to be putting the Mercedes M11 inside it. That's the M11.983. That's the around 200 horsepower supercharged 4-cylinder engine. That is where we are going to start from. So presently it's running the Mercedes M102 engine. That's a 4-cylinder single overhead cam, and we've done a little bit of tweaking to it to make it a little bit more reliable so as to serve us for a while. So right about now that we are about to change to the M111, we just want to give a little bit of an instructional video on how to go about the EFI conversion for the M102, because it's the parts for the KE injection systems are no longer being produced. So, and many people are stuck with the M102 with the rough idle, the late starting, the overfueling, underfueling problems with it. So this will just show you how to go about it if you want to retain the M102. You can pause. So I'll just give an overview on how to go about it. It was just a stopgap for us so that the M102 can work a little bit before we get all the parts necessary for the M111 swap. So here is the M102. We've removed some of the things on it, the air cleaner, that's the air filter housing, and some of the components for it, for the KE injection. So we've stripped it to make it a little bit easy for explanation's sake. So one of the main parts for the KE injection is the injectors. The injectors are mechanical injectors, meaning the way they operate is at a particular pressure they open and then they start supplying fuel into the engine. Now there is a plunger, sort of plunger here, but I believe the proper name for it is the AFM, that's the airflow meter, which also serves as the metering device for the KE injection system. So air is being sucked into this hole. As the air is being sucked, it presses this lever here. There's a plate that blocks it. It presses it down. As it presses it down, there's a fuel distributor here. This going down pushes into the pin of the fuel distributor, allowing more fuel into the engine. That is how the mechanical system works. But because the injectors, when they get old, you have to change them. The fuel distributor, you have to change it, and all other things, and these parts are no longer available. So what we do is we used an EFI system called Arduino. Now this is just an example of what can be used. This is just an example of what can be used. You can use any other standalone ECU for this purpose. You can use Rosefi, Max ECU, Mega Squared, and the list goes on and on and on. So, but for this particular conversion, we just made use of Arduino, to get the car moving for a while. A better system, which is still a little bit easy to come by, is meaning if you want to use electronic fuel injection, you need some basic components. So I will start from the source, which is every car runs on two things. You have the air and you have the fuel, and then you have the third component for spark ignition engines, which is the spark. So the fuel of this engine is stored in the tank at the back, and since it's already fuel injected before, albeit it was mechanical injection, there is already a fuel pump supplying fuel at very high pressure. So we don't need to change that component because the fuel pump is supplying enough pressure to run a modern EFI system. So we leave the fuel pump there. Now, after the fuel pump, you have your pipes that bring the fuel over, your filter and other things like that, which are just standard and you can leave them alone. You have the part that puts the fuel into the engine, which is the fuel injector. Now, you have to change the fuel injector to the electronic fuel injection type. So for this, we use the Bosch fuel injectors. You can come over and just show the orange injectors here. So we use the Bosch type, but you will see that we have 4 of them, since we have we've removed the air cleaner so that you can see a little bit better. So we have 4 of them. That's one for each cylinder. That's 1, 2, 3, 4. But the fuel injectors receive fuel from what is called the fuel rail. This is the fuel rail, this metal tube here. Now, the fuel rail has to have ports like holes to supply fuel to the injectors at specific points, which must also coincide with the point where the injectors must be for each port here. So what happened here is that, well, by sheer luck and ingenuity, we discovered that the M113 V8, the Mercedes V8, you know, it has 8 injectors for 8 cylinders. What we discovered is that half of the fuel rail for that particular engine, so half of the fuel rail for that particular engine actually lines up with the holes for the M102, so which is very, very convenient. So what we did here is that, you come a little bit closer here. What we did is we cut away half of that rail, so we are left with 4. So you can see 1, 2, 3, 4, and we blocked the hole. This is just using a brass soldering. So we clasped it together and we just soldered it, so it's soldered shut. It can't leak from this port and it can handle the pressure which goes into this place, about 40-50 psi. So, and you will see there's a supply here also. Now, you must be curious about what this is doing here. There are 2 types of systems used to get fuel into engines of this port injection type. You have the dead edge system and you have the return type system. So since we are only using half of this fuel rail and there's only one pipe to supply fuel to it, that means it has to use a kind of dead edge system which is returnless. But the 190E uses a return type system, meaning there's a supply hose from the tank and then it goes into the fuel rail. At the end of the fuel rail, you have your fuel regulator, your fuel pressure regulator, the FPR, and then you have the return, which is this. It goes back into the tank. Now, this filter here, which is from a Volkswagen Polo, this filter is from a Volkswagen Polo. I'm sure maybe other Volkswagen cars use the same fuel filter. It's a combination of fuel filter and fuel pressure regulator. So what we do with it here is we put the two pipes coming from the fuel system of the 190, the supply, and the return comes into this fuel filter here, and then it gives a pressurized output at a fixed pressure, and then that pressurized output is tapped, and that is what goes into our fuel rail. This is the major thing that would stop people from converting this engine to EFI. So I believe once you are able to get this, then you are good to go. But I must also talk about other ways in which this can be done. There is a particular Saab engine, that's SAAB, pardon my pronunciation, that also has the holes on the fuel rail perfectly matched for the M102 engine. So if you are in a place where you can get a hold of that Saab fuel rail, then you are also golden. Do you understand? So that way, and that one has the return type configuration. You may not have to use this fuel filter to kind of manage what we have here. So with this in place, your fueling is taken care of. Now, obviously air is already taken care of. The engine has a throttle body here already, so it gets air through that place. But we also need to know how much air is going into the engine, which was what the AFM was being used for before. But we have already cannibalized the system. We've removed the plate here blocking the airflow, so this cannot do that job anymore. So, but we are using Speeduino. Speeduino runs speed density, meaning it uses a pressure sensor, which is called the manifold air pressure sensor, the MAP sensor. It uses a MAP sensor to measure the vacuum in the intake manifold. From there, it uses that information coupled with engine speed and other parameters to infer the amount of air going into the engine. So that takes care of air metering too. So we have 4 injectors. All of them are wired here to the Speeduino. For this particular conversion, we are using the N02C. That's no overhang 2 channels, which is a Speeduino board designed by Weaver Markel. So you can check it. We'll put the link to all these things on the description of the video. So we use N02C. N02C is a 2-channel board. It can be configured to do 4 channels, but for this kind of arrangement, you ideally just need a single channel. 2 channel is plenty, and 4 is very, very, very good. So for this configuration, we are using 2 channels of the N02C, and the injectors are connected in pairs, 1 and 3 together, 2 and 4 together. Some other people use different arrangements, but that is how we did our home. So that is that with the fueling arrangement. Next, the Speeduino needs speed information. Meaning, what do I mean by that? It needs to know how fast the engine is rotating, the RPM, revolutions per minute. It needs to know the RPM of the engine. Now, for a typical system, you will have sensors like the crankshaft sensor, like camshaft sensor. So most systems use the crankshaft sensor for that purpose, and Speeduino supports that too. You can use a 60-2 wheel, which can be found in many Mercedes Benzes. For example, the M111 flex plate has the 60-2 pattern. You can bolt that into the M102 because there are 2 versions of the M102. Unfortunately for us, our home version has its speed pickup at the distributor, so we couldn't use the 60-2 configuration, but that didn't stop us from getting the job done. So I'll just explain our system, then I'll give pointers to a better way to do it. So what our system here is, you see we've retained the ignition side of this system. There's nothing wrong with it, it works fine. So this is the ignition distributor. The ignition distributor has a pickup. You see this green cable? There's a pickup here. So for every revolution, there is the sensor picks up the signal, and the signal goes to the ignition module here. This ignition module is what is tasked with sending, not sensing, yes, it senses too, yes, by the information it gets from this sensor. It uses that to know when to send a signal to the coil. It grounds the coil, and then the coil creates a spark, which then goes to the distributor, and the distributor routes the spark to the proper cylinder. So that's the ignition system. So the ignition system doesn't need to be touched. It works well. You can leave it alone. If you want to take over the ignition of the vehicle, you can also do that. But I strongly advise, if you want to take over the ignition of the system, for you to use the 60-2 pattern. That means you have the higher, how will I put it, the later years of the M102, which had the crankshaft position sensor at the back here. Ours do not have that. So that is that for that. So at this point, which is the ignition module also sends a signal out to the RPM sensor. Sorry, not the RPM sensor, the tachometer, the engine speed display in the cluster there. So, which shows the speed of the engine. That's the RPM. I don't know why the proper name for it escapes me right now. So I think you get what I mean. So it sends signal to the cluster, which the cluster uses to display the speed for the engine. So this is what we took over, and then send that information to Speeduino. So with that, Speeduino knows the speed of the engine. This is a 12 volt pulse. It's a 12 volt pulse. If you see, this is the green line. This green line, I hope you can see. This green line is the RPM output from the ignition module. It comes here too. So this is where we tapped our RPM information. You can see this cable. This cable goes to the Speeduino. So in the Speeduino, you are going to choose the option for distributor, since this is what we are going to be using. So if I step back a little bit, I will explain, just to give an overview. This is an overview video, not, it doesn't need to be so, it's not, we are not doing this to be so how will I put it, detailed, because this engine is moving out of this chassis very, very soon. It's just that we know that some people would like to retain this engine, and we just like to put this information out there for them, so that they can continue to put their car on the road, because there are countries which do not allow engine swaps. So now I'll just reiterate. You get your RPM from the tachometer output. This is the green cable. You get your RPM from it. You get your vacuum source from the intake manifold. Do you get that? So with these two information, that's all you need. Now if you want to go advanced, you can decide to install the TPS, the throttle position sensor. We did not make use of that because we just wanted to get the engine running, you understand? So you can install a TPS. I have heard that the throttle position sensor for the M50, that's BMW M50, can be grafted on the throttle body for this engine, and it will work, because the one that is there presently is just an on-off switch, which the KE jet injection just uses to do overrun and other things like that. So I believe with this small overview, you should be able to get started with converting your M102 to electronic fuel injection. If you need more information, you can just go in the comments, put something there. We'll definitely read the comments and try to get back to you. And if you need further details, maybe we can take some more detailed pictures or kind of scribble down diagrams to make the process easier for people that want to do this thing. So, but if I may advise, you can use Speeduino. It works fine. People have used it. I would say a better option would be for you to use Rosefi, because with Rosefi you can replace the throttle body with a electronic throttle body. So you can replace the throttle body with the electronic throttle body. That works fine, especially if your car is using the manual transmission. That would make it better. But if you are stuck with auto transmission, the automatic transmission, you have to retain the mechanism that pulls the load cable. I've forgotten the name for the transmission, which is what the transmission uses to sense how much load is on it so that it can shift properly. So you have to retain that mechanism if you are using the auto transmission. But if you are using the manual, you can just jettison all these things here. Jettison it, put your electronic throttle body, use Rosefi, and Rosefi even has the feedback, the lambda feedback built in. So you can just do that. In fact, it will make for a very, very, very neat installation. You can change. You can, if you want to go all out, you can remove the distributor, go to individual coils, all unplug. The sky is the limit for you, and then you have yourself a much more reliable engine that starts every time and will actually be much more efficient than it came from the factory. So let me also add, for Speeduino, the software you use for Speeduino is called Tuner Studio. Coincidentally, it's the same software you use for Rosefi too. It's also Tuner Studio. So whichever system you choose, you are good to go. So with that, you can change your parameters, you can change your VE table, your lambda targets, your overall fuel cutoff, your temperature. You can decide to use an electric fan, decide when it comes on, decide when it goes off, connect your fuel pump for it to switch off when you have stopped cranking, you know, all sorts of things. You can just take over the engine and do something great with it. So maybe if you need help, I can send the tune we are running on this to you, but it's a rough tune. It works very well, starts every time, so I'm sure it will serve as a good base file, and from there you can just take off. So, this is Modern Nice Classics. Thank you for watching. Don't forget to like and subscribe, because that will help us grow better. So thank you very much for watching. Bye bye.